Hello, my name is Manuel, and I'm from the University UAT-UAMRA, and I'm gonna talk about ammonia, how to produce it, the application of the ammonia, and the complex that produce it.
English applied to engineer in petrochemical process, the ammonia. Definition of ammonia. This compound is a mixture of nitrogen and nitrogen with an NH3 formula. This product is a colorless gas with a characteristic pungent smell. It's lighter than air and you can easily liquefy it due to styrene hydrogen bonding between molecules. The ammonia is miscible with water and aqueous solution and it can be expelled by boiling. It is used chiefly for refrigeration and in the manufacture of commercial chemicals and laboratory reagents. How to produce ammonia? There are a lot of processes behind the method of Haber process to produce ammonia, like steam reforming from natural gas, desulfuration, catalytic reforming, primary reformer, purification, conversion stage, elimination of CO2 stage, methanization stage, ammonia synthesis. Steam reforming from natural gas or GLP, the first step. This first part to obtain the ammonia synthesis is the steam reforming, starting from natural gas constituted by a mixture of hydrocarbons, being 90% methane to obtain the hydrogen necessary for the synthesis of ammonia. The next step is desulfuration. But before the reforming, we have to delete the sulfate that the natural gas contains. Use lime as a feedstock helping to remove the sulfate by the process of absorption. The next step is reformed, that is separated into stages, primary and secondary. When we have an adequate natural gas, we continue to do catalytic reforming with the steam water. Then, when the natural gas mixes with steam, it's in this moment that can get reforming process that can be separated into stages. Primary reformer, the first step or the first stage. The gas and the steam is passed inside the equipment tubes, where there is two different reactions. Strong endothermic reactions, and this reaction can reach temperatures around 800 degrees, and it's catalyzed by nickel oxide, and this process favors the production of hydrogen. And secondary reformer. The reformer outputs steam in the path step, mixes with air, and we can give the nitrogen necessary to do the stoichiometric synthesis. In summary, after these two stages, the gas composition obtained is approximately 12.7% of nitrogen, 31.5% of hydrogen, 6.5% of CO, 8.5% of CO2, 0.2% of methane, 40.5% of water, and 0.1% of argon, obtaining 90% conversion of hydrocarbon. The next step is purification. The process to obtain ammonia requires a synthesis gas for great purity that is why it is necessary to eliminate the CO and CO2 gases. Conversion stage. The next step is get the mixture into a converter when it's cool zone where the CO is transforming in CO2 by a reaction with the water steam. This reaction requires a catalyst that doesn't deactivate with the CO, and the reaction is carried out in two steps. Approximately 400 degrees with iron, 3 molecules of oxygen, and chromium as a catalyst, obtaining 75% of conversion. Approximately 225 degrees with a catalyst more active and more resistant to the poisoning, giving us the complete conversion. CO2 elimination stage. Following the CO2 is eliminated in a tower of different beds with potassium and trioxide carbon in countercurrent forming potassium bicarbonate. This is getting into 2 towers in a low pressure to absorb the CO2 and the baking soda convert in charcoal releasing CO2 that is subproduct that is used in some drinks. Methanization stage. The traces of CO and CO2 that is so dangerous for the reactor synthesis catalyst that is converted into CH4 that is methane. This process is made over a bed of nickel catalyst at 300 degrees. Ammonia synthesis. This is the final step to obtain ammonia. That's how you can obtain a synthesis gas with remains of methane and argon that acts like an inert. Then, the gas is compressed to the pressure of 200 atmospheres approximately, and it takes to the reactor where you can produce the ammonia over a catalytic bed of iron. Uses of ammonia. Most of the part of ammonia, like 80%, is destined to the manufacture of fertilizer like ammonium nitrate, ammonium salts, and urea. Another uses of ammonia includes fabrication of nitric acids, nylon, polyurethanes, cryogenic gas, and cleaning domestic products. Petrochemical complex that produce ammonia in Mexico. The petrochemical complex Cozolacac is located in the southern area of the state of Veracruz, near to the Gulf of Mexico. And this image shows us the production capacity. That shows us the air, the natural gas, and the vapor. And the distribution of ammonia shows us some vehicles that transport this product, this gas. Show us that some ships transport the product, some trucks, and the methods how to stock the product.